is your unit circle and a whole bunch of vocabulary. So it's short vocab, but these are all kinds of words, especially theta. These are a lot of words that I'll be using. So theta is a symbol. In other words, it's like a variable. So it's a variable they use for the measure of an angle, and it'll look like a 0 with a little slash through it. So if you see that, that's just like an x. So solve for x, solve for theta, same thing. Okay, initial side, you've got an initial side and a terminal side. So you're going to have the beginning position of an angle and the ending. So there's two different parts of an angle. One's going to be the start, one's going to be the end. The way you tell the difference, if you look here, is the little arrow on the inside. So it's going to tell you which way you're going to be going. So wherever you start, that's your initial side. The arrow is where it's ending, which will be the terminal side, the end. Okay, and then I have here that it's going to be positive and negative. There's positive and negative degrees. That's just telling you the direction. So if it's positive, you're going to go counterclockwise, just like we did with the rotations. They were counterclockwise. And then negative, just like the rotation, that would go the other way. So it went backwards when we did that. So if it's negative, you're going to be going the way the clock runs. So this one over here is an idea of a negative because this is the way the clock runs. So my initial side's where I start. I'm going the way a clock runs, so it's negative, and this is the side that ends, so it's terminal. Okay? Standard position. Standard position is when you're talking about an XY axis and your vertex is going to be the origin at 0, 0. Okay, your initial side is going to be the positive x-axis. So standard position would be like an angle in quadrant 1, pretty much. Okay, unit circle. This is an example of a unit circle. The reason why it's called a unit circle is because my center is the origin, and to any point on the circle, not just to these up, right, left, and down spots, but if you pick the point on the circle and you did the distance formula, it would be 1. So the radius of this circle is 1 unit, hence unit circle. Okay, so the radius is 1, the center is the origin. That's what we're going to be working with. So what we're going to be using is we're going to be finding the different angle measures, the different endpoints without a calculator. Okay, wrapping function, this one's not as important. This just associates points on a number line with points on a circle. A circular function, so this is just saying that there's t that's on the point of a circle, and that's kind of the first example, or the second example that we'll be talking about. So you'll get a point on a circle that's x, y. Those are the coordinates of t, and we're going to be talking about 6 trig functions. We've only really talked about sine, cosine, and tangent. We're going to be getting 3 more, but the other 3 are just sine, cosine, and tangent flipped upside down, so it's nothing that's too difficult. And then a periodic function, this is just the horizontal distance of a completed circle. So when it says it has repeated values, we start here. And so this is 90 degrees, 180 degrees, 270, 360. 360 is a full circle. Well, if they gave you a 450 degree angle, we're just wrapping around. So it's the same values, and you could just go around forever. So you've got 360, you'd have 450, you'd have 540. Okay, so it just keeps going. So you can have bigger than 360, and I'll show you how to figure out what degree that'll be in a normal circle. Okay, so we'll talk about all that stuff. So this one, name the quadrant. If you're talking about quadrants, I named them over here. This is 1, 2, 3, 4. Some teachers, I've seen them say before, it makes a C. So if you make a C, that counts the quadrants. This is quadrant 1, and then 2, 3, 4. So we make a C because that's the order in which you count them. Okay, so it says name the quadrant in which each angle lies. So if I'm talking these different numbers right here, this is my starting point because we're talking standard position. And then this is going to be 90 degrees. Another 90 is 180. I'm just counting by 90s. Another 90 is 270. And then 0 and 360, they're the same spot. So you just kind of start over. Okay, so if I'm looking for 50 degrees, I just want to find what 2 numbers they're in between. So 50 is right between 0 and 90, so that's going to be in quadrant 1. 208 is going to come between 180 and 270, so 208 is going to be in quadrant 3. And then I'm going to skip to 400. The way you're going to figure out where 400 is in a 360 degree circle is if it's more than 360, you're just going to subtract 360 until you get a normal number. So 400 minus 360 is just going to be 40. And 40 degrees is going to be between 0 and 90. So that's going to be in quadrant 1. Okay, now I got negative. That's why I'm going a different direction. So 0, it's still going to be 0, but then you have to go clockwise when you count. So this is going to be negative 90. This will be negative 180. So 180 and negative 180 are the same thing. And then up here is going to be negative 270. And then here would be the negative 360. So when you're using negatives, you got to go clockwise. And if we're talking negative 75, that comes right between 0 and negative 90. So that would be in quadrant 4. Okay, so these really aren't going to be questions they're asking. We're just going to have to be able to find out what quadrant we're in when they give us degrees. So these are going to be the points or the problems that we learned today. It's really only one type of problem that we're doing today. And I think I gave you, I can't remember how many's on the worksheet, but that's what we'll be doing today. It's just these types. So it says, let theta be the angle in the standard position. That just means it comes out starting on the x-axis, and we're going towards in quadrant 1. And it said the terminal side contains the 0.53. So it says find the 6 trig functions of theta. So this is the example they're talking about. They won't give you this. All you'll get is the sentence. So if x is 5 and y is 3, that means this would be 5, this would be 3. So I just made another bigger triangle over here so you can see what we're talking about. Theta is always going to be built around the origin. Okay? So maybe leave yourself a note like that if you don't know that. Always out of the origin. Okay, so in other words, this will be my theta. And then since 5 is your x, it's going to be here. And then 3 is my y value is here. Okay, so usually if you forget about SOHCAHTOA, that is absolutely super important that you know SOHCAHTOA. You're going to need it desperately. So we've got to find sine, cosine, and tangent. So if I do sine of theta, I'm supposed to do opposite over hypotenuse. So opposite is 3. Hypotenuse is missing. So I need to find that. So that's going to be the one thing that you need to find in all of these. And if you have a right triangle like we do right here, then that means you're just going to use the Pythagorean theorem. So I've got 25 and 9, which is going to give me 34. And make sure that you get rid of the squared. So you have to take the square root. So this right here is going to be the square root of 34. Which you do need to make sure that whether or not it breaks down. So it's 34, no perfect squares go into 34, so it's just going to stay. If it breaks down, which you will see, and I gave you one later, we'll have to work on it. You will have to break it down and not in a decimal. You'll have to break it down using radicals. So that's going to get me over the square root of 34. And you will have to rationalize the denominator, so no radicals in the denominator. No square roots. To get rid of a square root in the bottom, we just times by the square root of 34. So none of this is really new so far. It just the setup of the problem with the 5-3 is the only thing that's new. So right now on top, you're going to get 3 square root of 34. And on bottom, square root of 34 times the square root of 34 is just 34. If 3 over 34 reduces, then make sure you reduce it. Otherwise, that's it. So the sine of theta equals this. They just want the trig functions. That's all they're looking for. That's all we want. It's just those fractions right there. Next, cosine. So cosine is the adjacent, which is going to be the 5. So the adjacent over the hypotenuse. So it's almost the same thing here. So you're going to times by the square root of 34 over the square root of 34 again. So that's going to give me 5 square root of 34 over 34. And 5 over 34 doesn't reduce, so that's my cosine function. Tangent is opposite over adjacent. So that means I'm just going to have 3 over 5. Easy peasy for that one. Okay, our other trig functions that we're going to be doing, I wrote them down here. So I'm also going to have secant, cosecant, and cotangent. Okay, so with this secant, this is how secant will look. So it'll say SEC, this is cosecant, CSC, and cotangent is COT. So the way I wrote these, this is nothing that you have to memorize. So all you have to do is you have to switch them around. So the cosecant, that's going to go with your, that's going to be your inverse of sine. So if you think of it like this, like the C's can't go together. So you can't put cosecant and cotangent. They're both C's, so they can't go together. So cosecant is going to go, it's just going to be the inverse of sine. So you're going to take sine, which is opposite over hypotenuse, and you're going to flip it, which means it's just going to be hypotenuse over opposite. So cosecant goes with sine, so the SC goes with S, and then the S1 goes with C. So you have to mix them up. You can't put the S's together, you can't put the C's together. It doesn't work that way. So secant is just cosine flipped upside down. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. Okay, so you just have to take them and flip them. It's nothing fancy. And cotangent obviously goes with tangent because it says tangent with it. So instead of having opposite over adjacent, you're going to put adjacent over opposite. So all you have to do is take them and flip them. So let me go back up to where we were. So in other words, if I'm looking for cosecant, that just goes with sine. So all I have to do is flip this one upside down. I just take the original and flip it, because if you take this and flip it, it's going to get you a square root on the bottom. You don't want it. So I'm going to take the original and flip it. It's just going to be the square root of 34 over 3. And you don't have to do anything because there's no fraction, or there's no square root in the bottom. Cosine and secant go together. So all you have to do is take the cosine and flip it. So that's just going to be the square root of 34 over 5. And then cotangent, you just take tangent and flip it. So it's just going to be, did I put 4? I sure did. Sorry, it was opposite over adjacent. That was 5, not 4. So cotangent, instead of 3 over 5, it's just going to be 5 over 3. So this is what you'll be doing. This is all you'll be doing today, is labeling all of these. This one is a little bit more tricky because it gives you degrees. It says find the 6 trig functions of 315 degrees. So remember, I've got 90, positive goes counterclockwise, 180, 270, and 360. So this is going to be a big thing that we do tomorrow, and we'll really be getting in this tomorrow. So 315 is going to be in quadrant 4. Now you always, and what we're going to learn tomorrow, you always want to go from the x-axis. So you never want to find an angle going off of the 90 or the 270. 100% of the time, you want to find an angle going off the 180 or the 360 line, okay? And since 315, if you do this and subtract it, that's going to give you 45. So that just shows me that it's 45 degrees away from the 360. So this is a 45, 45, 90. 45 is going to be your theta that we'll be using. Okay, the reason why this one's tricky is because they didn't give you a coordinate like that first one did. So we have to remember our 45, 45, 90 degree triangles and our 30, 60, 90 degree triangles, which I know a lot of you weren't fans of, but you have to know it and you can't do the unit circle without it. So if this is a 45, 45, 90, what we had was we had 1, 1. Actually, we used z's. We did z, z, and then z square root of 2. But you don't need the z's in this case. All you need are the numbers. The only thing that's new and different that you have to figure out is this is a positive one, but this right here, this is going down, so that would actually be a negative. So we'll deal with a lot of this tomorrow. The hypotenuse will never be negative, ever. Okay, so it's only either the x value or the y value. So if you were over here in quadrant 2, then your x value would be negative and the y value would be positive. Okay, if you're in quadrant 3, this would be negative, and so would this. So both would be negative. Quadrant 1, positive, positive. So it just depends on where your triangle is. So that is more so for tomorrow, but I wanted to introduce it today. Okay, so for my 6 trig functions, I've already got all the numbers that I need, so I don't have to figure out anything this time. So sine of 45 is going to be opposite over hypotenuse. Square root of 2, sorry. That's terrible. So you have to rationalize the denominator again. So we're going to times by the square root of 2. So negative 1 times the square root of 2 will just look like this. Square root of 2 times the square root of 2 is just 2. So there's your sine function. Cosine is supposed to be adjacent over your hypotenuse. So it's going to be the exact same thing without the negative. So I'm just going to give you this. Okay, and then for tangent, I forgot my theta. For tangent, tangent is supposed to be opposite over hypotenuse. So -1 over 1, which is just -1. Your other trig functions, sine goes with cosecant. Okay, so all you got to do is take this and flip it. So it's going to be square root of 2 over -1, which is just negative square root of 2. Make sure you reduce. Nothing ever goes over 1 unless you're dealing with a ratio. Cosine goes with secant. So it's the same thing. It's just without the negative over here. And then tangent or cotangent, we're going to take this and flip it, which is still going to be -1. So those are my 6 trig values. This is more so for tomorrow. So you won't have to do this today. I wanted to introduce it to you though. Okay, so I gave you one more of these because this is the thing that you're going to be dealing with on your homework tonight. So this is all it'll show you. It says let theta be the acute angle in standard position. So then we're starting at the x-axis, whose terminal side, and then we have this as my terminal side. So if you think of that on your xy axis, like this, +2 and -8 is what we're going to be looking at. So that's your x and that's your y. So if I go and make my triangle at +2 and -8, like that. There we go. That's going to be the triangle I'm using. So it's not really a big deal at the position, just so that you know that the x value is the 2, the y value is a -8, and you need to know where theta goes. That's the important thing. Okay, so the theta is always going to be built around the origin. So now I still need to find my hypotenuse. So I've got 2 squared, -8 squared. So I'm going to use my Pythagorean theorem for this. Make sure if it's negative when you square it, it's still going to be positive. A lot of people make that mistake. So in other words, a lot of people, when you guys put it in your calculator, and you put -8 in your calculator, a lot of you guys do this. And that is not correct. Okay, because what your calculator thinks you're doing is you're timesing -1 times, and then they're doing 8 squared. So 8 squared, 64 times -1. That's how they're looking at it. So for you to say -8 squared, it needs to look like this. Okay, that means -8 times -8. So if you're going to use your calculator, put it in parentheses. It's always going to be positive when you square it. So that gives me 64 plus 4, which gives me 68. And this one is going to have to break down. So when you break this one down, let me see, 4. This is the square root of 4 times 17. Okay, so I don't know. I think you guys did the factor trees. So I think most of you guys did the factor trees. This is how I've always done it. I just find a perfect square that goes into it. So this is just 2 square root of 17 for your hypotenuse. Some of you guys do it this way where you break it down with the factor tree. So 2 and 34, 2 and 17. And then the buddies, the ones that have the pairs go outside. The 17 doesn't have a buddy, it stays inside. Whichever way you guys know how to break down square roots, you do it. But this is what I need, no decimals. We're doing no decimals on these. Okay, so I've got my 3 things. Those are the things I need. For sine, I'm going to be doing the opposite over hypotenuse. So I've got -8 over 2 square root of 17. 2 things you got to do. First of all, -8 over 2 is -4. So you can reduce that. Then you have to rationalize the denominator. Okay, so that is going to give me -4 square root of 17 over 17. And 4 over 17 doesn't reduce, so there's your sine function. Cosine, same thing, except I've got adjacent over hypotenuse. So I've got 2 over 2 square root of 17. These 2's go away. You still need to rationalize. So I've just got the square root of 17 over 17. And tangent is going to be opposite over adjacent. So -8 over 2, which is just -4. Okay, when you switch and do the other trig functions, you've got cosecant. So that's just going to be sine flipped. I'm just going to use this one and flip it because that's the reduced one. So square root of 17 over -4. Doesn't matter where your negative goes. You can put it with the bottom, you can put it with the top, or you can put it out front. It's all the same thing. Okay, and then secant. Secant is going to be this one flipped, so square root of 17 over 1, which is just the square root of 17. And then cotangent is this flipped. So you have 2 over negative 8, which reduces to a negative 1/4. Those are your 6 trig functions. So those are the things you're going to be dealing with the most. Now, the only other thing I put on there is radians. So a radian, because you have your degree mode and your radian mode. So radian is just a unit of measure for angles. So it's a different setting on your calculator. It's the difference between degree and radian. So you can change those. The arc is the same radius as a radian. So remember we were talking about a central angle in a circle? So a central angle looked like that. The arc is equal to the radius and creates a radian. So the arc right here, they're saying the arc is equal to the radius. And so that makes a radian. So full circle, 360 degrees is 2 pi. So that's how radians are measured. They're in terms of pi. So 360 degrees is 2 pi. 180 degrees is a regular pi. So to change it, and this is the important part, to change it, you have to times by this fraction. So if they give you 7 pi over 9, all you have to do to change it to degrees is we're going to times it by 180 over pi. So all that does is that makes pi go away. Pi over pi is 1. Then I think you can either times by 7 and then divide by 9. I think it's easier to divide first because it makes the number smaller. So if I do 180 divided by 9, that's going to be 20. And then I can just do 20 times 7. And that's much easier to do in your head. So 7 pi over 9 is radians. That's the same as 140 degrees. Okay, and then in this last one, I've got times 180 over pi. So the pi's will go away. And then if I do 180 divided by 20, that's going to give me 9. And then I can just do 13 times 9. And I believe that's 117 degrees, if I did my math right. If not, I'm sorry. But that's all you got to do. So there'll be a couple of these on the homework today. And then I think the rest of them are all like the top ones with the triangles. So if you need my help, I'll be on the Google Meets. There's also the Google Meet 7 period with Ms. Wise if you need it. So good luck, and I will see you tomorrow.